In this last video, I'd like to show you some of the specifics of this sigmoid function, which is a link function taking the scores we've given to our sentences and translating them into probabilities for us, which is very convenient. If s of x here denotes our score function, then the sigmoid function takes that score, flips the sign on it by putting a negative sign there, and then we consider 1 over 1 plus e to that negative score value. And that's the function that's going to take as input the score of a sentence and provide as output the response of this, that probability that we were seeing in that beautiful curve on the previous page. So what I've shown down here is a table of a handful of values that were in there, just so that you can see that this sigmoid function accomplishes what we want it to do. As we saw in the picture, it really is true that if you put 0 in for the score of something, the output that you get is 1/2, or a 50-50 chance of that being a positive review or a negative review. We just don't know at that point. If you have a score of even 2, there's a very high probability, an 88% chance, that that is going to be a positive review. -2 has a very low chance of being a good review. And by the time you move out to 5 in either direction, you get these very extreme chances of a review being positive or negative. So if you think back to the example that we did, we had scores of -7, -0.4, and positive 5.8. If we were to use that scoring function that had that little table of examples that we did in this set of slides, we would have felt incredibly confident that the sentence x1 was a negative review, and incredibly confident that sentence x3 was a positive review. And if that seems a little bit unbelievable to you, it's because I just made up those values in that table at random. And so I did a very poor job of doing that, because as much as I can read those sentences and I think that those classifications are correct, I think they're a little bit extreme. So that's one of the things that we'll be doing this week when we get to our next Jupyter notebook, is we'll be thinking about what those coefficients really ought to be on those values. The spirit of what they're doing should be like the table that I showed you in these slides, but the actual values should probably be a little bit different. This kind of model is often called a logistical regression model, just to get some vocabulary in there for you. And what I'd like us to do as a thinking question is to think about returning to a very simple model. Let's just look at some sort of arbitrary constant, and then we'll have a weight on v sub 1. Let's think about v sub 1 as the number of greats that appear in the review, and let's think of v sub 2 as the number of disappointeds that occur in the review, as we did with our first example, except we'll allow to have these weights a1 and a2 there. And we'll use our sigmoid function to translate scores into probabilities. And one of the things that we'll explore is what happens if we make these a sub i's very large? What will happen to the scores? And then in turn, what will happen to our probability model when we make that kind of a change? How about if we do something more extreme, which is to take these a sub i's and make them very close to 0, make them very small in absolute value? What's that going to do to the scores that we're assigning to sentences? And in turn, what is that going to do to the probabilities that we're attributing to these reviews? Those are some things that we'll need to think about, and it's worth thinking about those things on a small scale before we move up into more interesting models that have many more nuances and many more variables.